Hi guys, welcome back to In Case of Econ Struggles. Today we're continuing to talk about central bank behavior and loss functions. Specifically, we're going to talk about what the central bank does in response to observed shocks to both the IS and the LM curve. If you'd like to jump around, timestamps are below, but let's go ahead and get right into it with a quick review of the loss function. So remember that in this loss function, we have output pain and inflation pain. So we are going to square the difference between y and y star and pi star. That square is because I want to feel pain if the output or inflation is too high or too low. For this example, we're going to say that the output target is 0 and the inflation target or pi star is 0. I'm going to throw a half in here just for fun to make the math a little easier later on. Just like we talked about in that intro, we're going to throw this loss function into the 3-equation ISLM model. We've got our IS curve with the random shocks. We've got our LM curve with our random shocks. Both of those shocks are mean zero white noise shocks. And again, we have our loss function. Now notice that in both of these, we have an expectations augmented IS curve and an expectations augmented Phillips curve or LM curve. How are we going to deal with that? What can we reasonably expect of people's expectations? Well, it's a known fact that the central bank wants the output and inflation to be at their target, which we know are 0. And people think that the central bank are pretty good at their job. They think they're pretty good at getting the economy to be stable at those targets. And since I, as an individual person, know that these shocks are random white noise shocks, it's pretty reasonable of me to expect that tomorrow output and inflation should be 0. Now we can think about whether or not that's a good expectation more generally, but in this model, it is a good expectation that the general public should think that tomorrow both the output gap and inflation should be 0. The reason that's useful is because then we can plug in zeros for these expected values today of yt plus 1 and the expected value today of pi t plus 1, and that's going to help us really simplify this math. So I'm just going to go through, I'm going to plug in the fact that we have a y target of 0 and a pi target of 0, so I can just take those out. I know what y is, I know what pi is, so I'm just going to throw those into the loss function. So here is y and here is pi. Pi contains y, so I'm just going to throw that in again. And this is now our fully simplified loss function. And we can think about, all right, how do we determine from this loss function what the central bank is going to do in terms of the interest rate? Well, we know that the central bank is setting the interest rate r, so I can take the derivative of this loss function with respect to r, and that should tell me what my ideal interest rate or my R star is. So let's go ahead and start doing that. I'm just going to take the derivative. It's going to be sort of messy, and then I'm just going to simplify. I'm simplifying all the way down until I get to my optimal R, until I get to my optimal interest rate. My optimal interest rate is just going to be 1 plus k squared over 1 plus a squared. So maybe I'll take this out just to make it a little easier to read. And now we can use this ideal interest rate to think about those predictions we made earlier. Those predictions we made earlier were that the central bank should fully respond or fully counteract observed IS shocks. The central bank should only partially counteract observed LM shocks. And we guessed that people should expect yt plus 1 equal pi t plus 1 equals 0, but we can also check that when we figure out what exactly y and pi are. Let's start off by thinking about output. So output today and the expected value today of output tomorrow. So again, here is our simplified RT squared or ideal interest rate. I'm just going to plug that in to our IS curve here. Notice that the IS shocks are completely counteracted. This is a -1, this is a +1, they cancel out, so that our output today only includes the shock to inflation, which means that if I take the expected value of yt plus 1, it's just going to be the expected value of this mean 0 shock, which is 0. So it is a reasonable expectation that the output gap tomorrow will be 0. The only thing that's affecting output today is the shock to inflation, because we have fully counteracted the shock to the IS curve or the shock to output. So again, we can do the same thing with inflation. Here is our simplified ideal real interest rate, or the interest rate that we want to choose. Here is the output today that comes out of the ideal interest rate that we just talked about. Here is our value of inflation with those random shocks. We can plug in and simplify. We're going to get this value here, which again only consists of the shock to inflation, and we can take the expected value of that tomorrow. We take it forward 1 period, so this is 1 over 1 plus k squared et plus 1 pi, which again, it's a mean 0 shock, so it's equal to 0. So it is still reasonable for people to expect today that inflation tomorrow will be 0. So hopefully this gives you a quick run through of the math and the steps to solve the central bank loss function for observed shocks. The next video, we'll talk about unobserved shocks and what that means for central bank behavior. If this was helpful, make sure to like and subscribe, and we will see you next time for another case of Econ Struggles.